Okay, good afternoon, everyone. Welcome to this webinar of using AI with RPA. We have quite a few people today. Thank you so much for joining. This is going to be an introduction, very basics of AI and machine learning in context to RPA, and we'll go through the details and go through the topic, and we'll have a question and answer session at the end of this. Um, I have two colleagues with me. I am Ashish Nangla. I am the CTO of Accelerate, and I have Vachan and Ramy with me as well. Vachan is a lead machine learning engineer with us, and he's part of pretty much all of our machine learning projects and makes sure that they lead to success. Ramy is a senior machine learning engineer. He too has a lot of work that he does in most of the AI for RPA projects that we do, and we'll talk about some of them soon, but we're going to talk about the basics and fundamentals of AI and machine learning with RPA as of now. Okay. Uh, the objective for today, the objective for today would be to understand, as I said, basics of AI and machine learning to prepare as a foundation for our next two webinars. Uh, Today we're going to talk about the introduction. The next two will be about implementation, and the third one would be the typical use cases around our AI. Uh, in the implementation, we would talk about really how to go about implementing such a use case, and then we're going to talk about what are these use cases, what are the we may also discuss a few things that we have done in the past so that you guys can see what the potential for AI is under RPA. Okay, let me give that a start. So where does this actually fall under? This is something that we carry as a theory here at Accelerate, that business processes, comprise of these following elements, and what differs in different use cases is the proportion and of course the details of it. But essentially, all use cases for business process and automation have these problems that you have to tackle some proportion or the other. Okay. Um, there are various solutions to tackling some of these problems. We know we use RPA to do a lot of user actions and user activity. And there are other examples like IDP, which is intelligent document processing. There are APIs, there's business rules engine, there are chatbots. All of these are somewhat are equipped to solve some of these problems, or most of these problems, or are solutions to most of these parts of or components of a business process that you do. So today we're going to talk about AI and ML in terms of how do you solve educated decisions that are made as part of business processes, and while you're automating that, how are you going to replace that? Essentially, to making sure that you have more coverage of your automations. So if you are able to do, if you have an RPA bot, and that is RPA or user actions is 50% of the work, 20% is educated decisions, and maybe documents and business rules or other parts. If you're able to do RPA very well, you're able to cover the 50% user actions that we are talking about. However, there's still more coverage needed, and what people tend to do is tend to use human in the loop, tend to use user interfaces, email, file drops, a whole bunch of other ways of exchange between users and actual humans, and then the user actions. So in this case, we are going to talk about more coverage. How are we going to gain more coverage of this processes in terms of being able to use AI? Okay. One of the things that I wanted to talk about, where there is a hype. So I would, in my sense, when I look at AI, I feel that it's it's not there yet. So what are we talking about? This is one of the things that I mentioned that we expect. When I was told about AI when I was younger, we thought about AI to be this, the Terminator and other stuff, and the image on the right just shows my age, and my colleagues Ramy and Vachan have no idea what this is, but I'm hoping some of you understand. But this is what we were expected for AI to be. However, if you see AI today, you are more looking at simplified simplified robots and things that are actually taking care of just one and not multiple use cases. Um, why is there such a buzz now? What has changed? AI, and if you see, when we were talking about AI and machine learning and statistical learning as part of that, which is actually a predecessor of that, I would say. Things have been around for a long, long time. What is the buzz now? I think what we believe is causing this change is, of course, the fact that storage and compute have become cheaper. I used to buy stuff. Storage was so expensive. You had to buy all these CPUs. Cloud is making it much more easier now. I was able to spawn off, workstations for AI very, very quickly in a matter of minutes, or which was not even possible a few years ago. Enough data is being generated. Yeah, of course, I can give you examples of Facebook and Netflix and YouTube. But if you look at a typical organization today, a typical enterprise organization, they generate a lot of data. I mean, they are able to retain a lot of data. They're able to, look at data more carefully, and everybody is very insistent on looking at in understanding the data they have captured. Because storage were cheaper, and also I would say a lot of data warehousing projects got completed earlier, right? Everybody's now maturing into looking at the data that they have captured, and then further looking at how they can use this even better, right? So there's enough data now so that they can now be used for AI and machine learning. The other thing we see is technology is more accessible now. We have open source libraries. Pretty much everything that we do in AI is either open source or available on cloud. So um, in fact also the combination where we have stuff open source stuff on the cloud, so it's best of the both worlds as well. And if you see the velocity at which a lot of these things are happening, there's new stuff every day. There is pretty much for us it's a constant challenge of continuously learning and understanding what new things are. There, this says, right, 40% of all patents that got filed mentioned machine learning. Yeah, some of them maybe just for the sake of it, but there is still good amount of understanding in the industry now about machine learning and AI that are happening in this. In in terms of looking at all of these things together, I think that is what is fueling the use cases for AI and machine learning, and I guess a lot of that is not just the buzz, but your ability to actually take these use cases and take them to actual business cases, I would say. Okay, Vachan, you want to take this up?
Yeah, thanks, Ashish. Thanks, everyone. I'm Vachan. Uh, yeah, I'll explain the slide once I explain you, like, give you the brief introduction for machine learning. Ashish, can you turn on next slide? Okay. Uh, Yeah, I will. In this slide, I will give a brief introduction to the machine learning. What exactly is machine learning, and how do we apply machine learning in the business processes? So, yeah, if you look into the traditional programming, what we got is the traditional programming is written in such a way to handle all the possible scenarios. So, business processes are a set of scenarios that we kind of handle through. So, for each scenario, for each input, we know what exactly we need to do. So these are set of decisions that we kind of program. And if the business gets those particular inputs, we process them by set of rules we already defined in the programming, and it will give you the result. So as Ashish explained before, there are some of the processes where intelligence is required, where it cannot be it cannot be programmatically written in such a way that business can handle all possible scenarios. There is some kind of intelligence is required. So that's where we go to the machine learning. So machine learning is a kind of different from the traditional programming. So the input will be data, and result. So what I mean by result is, for example, let's say if a business process, in a business process, they are using some kind of intelligence, human intelligence to take all the decisions. So they have a lot of data for past historical data for past so many years. So they know the data, what was the input data, and they know what was the output, what are the decisions they made based on the input. So the machine learning, we take both the data and the result, and we get the program. The program is nothing but the machine learning model. So what we can do is in future, we can use that particular machine learning models to make that particular decisions automatically. So it's like we are collectively taking that particular models and collectively taking that all the particular decisions and making it as more a kind of program. So in future, the machine learning models can take the decisions automatically. Yeah, so machine learning is a part of AI. Yeah, so the applications of machine learning can be diverse. It can be tabular data, it can be image data, it can be documents and all those things. The applications are diverse in nature. Um, okay, so this is yeah, this particular slide will give the entire end-to-end application of machine learning, how we kind of use the data, how we build the model, and how we use the model, right? For example, in the slide we have taken a loan default model. The loan default model is commonly used different industries. So
What is
yeah, here
out for some reason?
can you hear me? Can you
No,
hear me?
we can't hear you.
It's cutting off, Vachan.
No. Okay, then I'll take this over and then you can continue on the other one. So I guess what you guys are able to see is a typical machine learning project or a deliverable of a machine learning project where we take a bunch of input data, which is in this case we were talking about a loan, say mortgage loan system. So you would take all the input data, what you're getting from the customers, and the past experience. So if you think in this case, we were trying to do loan default, for example, you would get exactly what kind of a loan default rate you have. You would use that to train the machine learning model. So in this case, there is the programming is pretty lightweight, but you're not capturing every condition. You're not writing if and then conditions on if the credit score is greater than this and the status this and stuff. You're not writing all these things. You're essentially training the model based on your past experience and the data that you had at that point of time, and you choose different algorithms for that. So we'll come back to that and understand what algorithms are and different types of algorithms. And essentially what you generate is saying, okay, these are the conditions that actually satisfy that particular output. That's what we use for training. There's a lot of data that you provide that we use for that. On the other side, once we have finished with the training, we start testing the model. So we generally look at the data that you had provided or somebody had provided us to train these models. We look at that and come up with some kind of a testing criteria and come back with accuracy on how well the models did and how well the algorithm is performing. And sometimes we have to choose between multiple algorithms. So we would use a bunch of algorithms, train multiple of those, and then test and figure out which ones actually work better in certain scenarios, in certain cases, and certain data. And then once we have finalized with that, then the output is the model where we actually use it for predicting. So you would send in new input data, something that the model has not seen or the algorithm has not seen earlier, and then it starts giving you predictions. And of course, it's based on the accuracy of that. Yep. Okay, Vachan, you want to try?
Yeah, sorry, I lost my connection.
So much better.
Yeah, thanks, Ashish. Okay, so Ashish explained what is the machine learning and how we apply and what are the kind of applications that we kind of solve using machine learning. So one of the common question asked is um, like what are the types of machine learning and how, where can we fit what kind of models and all those things. So machine learning can be classified into three separate segments, the machine learning algorithms. One is a supervised, unsupervised, and semi-supervised. So supervised is something in the previous example we mentioned, we know exactly the data, we know the results. So we can use the machine learning to kind of gather that particular intelligence to build the models. And then the machine learning models can take the decisions automatically. So in order to build that particular models, we need the data and we need the labels. Labels are something kind of decisions they have taken in the past. So supervised learning handles those kind of problems where we have a data and we have labels. We kind of build the models and we implement it. Second is unsupervised learning. Unsupervised learning is applied where we have the data, but for some reasons we don't know the results. We don't know the output labels. So we use in that particular case we use unsupervised models. Unsupervised models are kind of used to build the machine learning models without any labels. So there are various machine learning algorithms which can handle this particular task. So that's the unsupervised. And semi-supervised is a class of algorithms that where we kind of a deal uh, in a business process. They have a lot of data and they have very few. So we kind of mimic those particular things and take the decisions automatically. So in the semi-supervised learning, we don't require huge number of labels or labeling. We take care of the data with the few limited labels and we build the models based on it.
Ramy, you want to talk about various areas of AI and some evolution?
Sure, sure. Sounds good. So thank you, Vachan and Ashish. That was great. That was really good description and explanation of kind of how machine learning works. And what we're trying to do really is we're trying to give you guys a clue or an idea of what we do when we do machine learning and what machine learning is, so that you can kind of have an idea in your head of what it is. And of course, at the end of this, feel free to ask us any questions. We can answer anything that you want. So, uh, so AI, of course, has many different techniques and many different algorithms. And there's actually an evolution of these algorithms, both in when they came about, so when these techniques were invented and started to be used, as well as in complexity. So over time, if you look at these algorithms, you'll see that as time went on, the algorithms that exist, a lot of these are very recent. If you look at that, you'll see that the complexity increases. Uh, so this is a pattern that you see in sort of machine learning algorithms. So let's talk about these algorithms and what they do a little bit. So on the left-hand side, you have the statistical learning algorithms. So a lot of machine learning simply started with statistics. Logistic regression, for example, was actually invented way back in 1958 as a statistical regression technique, um, uh, which that's a very simple model, and that's a linear model, which if you don't know what that means, it means that the relationship between the input variable and the output variable is going to be linear, which you can think of it as on a graph, or if you know some math, you know that the formula is not going to have any polynomials, not going to have any exponents. It's a very simple linear relationship. Uh, it's basically a very simple model. It can't model all functions, but it can model linear functions, and that actually turns out to work in a lot of the cases. If you know some economists or econometricians, people who do econometrics, a lot of them use linear regression and logistic regression. And those are sort of two sides of the same coin. Linear regression is sort of for when your output is a number, some sort of whole number or decimal number. All right, let me go quicker because I just got a notice. And logistic regression, as opposed to linear regression, is when you have a classification to do. So is it label A or label B? And then these are sort of different kinds of flavors of these algorithms. We have decision trees, which are really powerful. You can extend that if you use them in aggregate as a random forest, which is very powerful. And then we have nearest neighbors. Then we go on to neural networks. This is what you may know and what looks like a cognitive architecture based on sort of neurons and how these neurons interact. What's interesting about neural networks is that they're a universal learner, which means that they can actually learn any function that exists that you can define. So a linear model can only learn linear, but a neural network can literally learn any function that you can think of, not just linear functions. And our neural network is based on a perceptron, which is itself pretty old. You see here it says 1969, but over time these perceptrons started to evolve and evolve and evolve. And now we have algorithms that are much more sophisticated and much more powerful. But, okay, so, and they're differentiable, but we don't have to go into so much detail right now. And then we have deep learning, which is basically a neural network is made up of these simple perceptrons strung together one by one, layer after layer. And when you have many, many layers in this neural network, then that's what you call deep learning. So deep learning, you have many different layers, and then you can have many different styles, such as convolutional and recurrent, which describe how these neurons are connected together. And they can have different strengths. So convolutional neural networks are really good at image recognition, while recurrent neural networks are really good at natural language processing and all sorts of processing and prediction and even translation with text or languages. You have transfer learning, which is when you use a previous neural network to make your neural network better. And of course, you can scale these up, and the more you scale them up, the better they get. That's how it works. So next slide. Great. All right, so we talked about all the different types of machine learning there, and Ashish and Vachan gave you an overview as well. So now we're going to talk about what sorts of problems do we have. So a problem is often kind of classified into what sort of output does it have. So you can break these up into these 4 different categories that you see in front of you. So scoring. So it says, what is the probability that the customer will default on his mortgage loan? So yeah, so as we were talking about before, there's kind of linear regression and logistic regression. So scoring would be what linear regression would do, which is it's trying to predict a number. It's trying to say, okay, there's an 80% probability that this customer is going to default on his mortgage loan. And because we know that, we're going to take some sort of action. Maybe we're going to, for example, sell the loan. We're going to cancel the insurance, something that makes sense for our business case, if we can predict that. So that's scoring. Classification, that's another type of problem. That's when you're not trying to predict any number. And a number, it can be probability, it can be a price of a stock that can be done. It can be even the temperature of the next day if you're doing some sort of weather forecast. So that's a number. But classification, it's not a number. It's like a category. It's like an objective class label. So if you're looking at customers again, we can talk about what category of customer is this. So you might have like three different categories of customers, and you might kind of be binning them into those 3 different categories, and based on what category they're in, you could be taking different actions on the customers, or it could be describing their behavior, and so you better understand your customer base. So classification is, again, very powerful, and it can be done with some sort of customer base, which is a widely used application. And it can be done with also image recognition. It can also be done with document classification. So what document am I looking at here? What is this? Is it a government document? Is it some sort of health document? What is the page that we're looking at? That can all fall into classification. We have we can also talk about decisions. So say you're a credit card company and there are some transactions going on in your database, and you want to ask, is that a fraudulent transaction or a true one? So based on historical data, we can use basically any machine learning algorithm we want, and we can try to predict if a certain transaction or a certain behavior in your database of transactions is fraudulent or not fraudulent. And that's, again, a very common use of machine learning. It sort of can be talked about as outlier detection, where you're looking for outlier numbers or outlier data points in your data to be looking for what's out of the ordinary. And you can model this in various ways in machine learning or normal distributions, etc. Okay, so right. So next, information extraction. What is the income of the customer given a space stub? That's what we do kind of with a lot of our intelligent document processing. So we can kind of read this, and there's a subfield of machine learning called OCR, optical character recognition. That's what you call it when you're looking at a document and you want to see what does the text say, and you want to understand that. So next slide. All right, let's go quickly through this because we're getting over time. So how does AI fit into RPA? As you can see here, AI activities can augment RPA and human activities in an end-to-end automation to improve process coverage and automatability. So many things in RPA, such as I was just saying, intelligent document processing, reading a document, classifying a document, it's not easy to do with RPA, and it can only be done with machine learning. And so those things that can be better done with machine learning, and that machine learning is its purpose is to do those things. That's what we want to use machine learning for. Yeah.
Perfect. So I guess I'll take this up again. So coming back to the fact that what is how do these projects differ, right? So we are doing these typical RPA projects, and now we have to talk about using AI, right? So there is some significant difference between how things are looked at. These are some points that I thought would be good for you guys to know and understand from how these projects differ, right? So typically, when you're making RPA, the programming is more logical. You have more conditions, and everything is either true, false, and yes, no kind of situations, and there are like finite number of conditions that you go through, and you have all these predetermined. However, AI, it's more subjective. Things like the 60% cancer rate. So you have to look at subjectivity rather than an absolute yes no. So you have to understand how to interpret that. RPA, you just need testing data for a few examples based on all your conditions, just however you're trying to test. However, AI needs training data, so that needs typically is a need for a lot of data. On the other side, RPA is to simulate human actions. AI is supposed to augment those actions or actually replace some of the decision making that they are doing. RPA accuracy is predetermined. If a file is dropped and you're opening in Excel, if the Excel format is fine, you're going to take data and enter it into a system, for example, right? However, AI, accuracy is better known when your training and testing is completed, and you only get to know how well you performed only once you have finished with training and selecting the right algorithm and things. Typically, RPA dev team has RPA developers. However, AI needs data scientists, similar people to what Vachan and Ramy do for us. Skill sets are completely different. There's technical skill sets, and of course, there's the whole data science and machine learning and AI that they need to do. Other than that, the technical skill set is also slightly different. That's pretty much what I would say would be the differences. We would go in further details. However, at this time, we will take questions, and once we are through with that, we can talk about what next we're going to do in the next sessions. So Megan, would you want to take up a few questions?
Yes, so there's a couple that were submitted in the chat, but if anyone has any else, feel free to interject. The first one is, Can we test the feasibility of applying machine learning to a project before investing? If yes, how would you guys recommend to do it?
Knowing accuracies beforehand is difficult so far. We can get feasibility very well understood whether something is done or not. The other thing is also a lot of experience. We look at projects and we can definitely say something is easier or not based on our experience doing some of these things. However, this is uh, doing somebody told me that AI is just like digging a well. Only when you have finished the effort of digging the well, you realize there's water or not. But of course, there's now techniques like probing and making sure that there is something that's going to work for you or not. So a lot of experience from our side, a lot of use cases that we have worked with that has helped us in the past to understand what kind of accuracies should we expect, and also there are good industry benchmarks like there are models that essentially are now there are competitions and leaderboards on most of these algorithms, and we see constant updates on them, and some of them have surpassed human human error rates or human accuracy rates, sorry, and some of them are way below, right? So we understand what kind of a solution that is on basis of that. So I guess there is no straightforward answer to say yes, there is a quick way to understand the accuracy.
Okay, the next one is, what is the most common challenge you see in AI ML projects? Quality of data, finding business value, tools, or something else?
So far I don't believe finding value and some of that has been a problem. In fact, explaining people what AI is and whether this is something is a good use case for AI is also not been a problem. I think the biggest problem has been data, and being able to give data and the right data in the right amount of time. Organizations we worked with organizations that have been capturing data for the last 40 years in nice mainframe systems and then nice data warehouses, and have thousands and thousands or millions of records. However, somehow still being able to the process of getting this data out and giving it to us for training and stuff has been a challenge regardless of the organization, I would say. So that's something that commonly we find as a hurdle.
Okay, there's one more. How can we scale the models up and down based on business needs?
So various things. I mean, if there is technical scalability, and of course there is the functional scalability. Vachan, you want to take some of the examples that we did so far in terms of scalability?
Yeah, sure. So the scalability part of the machine learning is almost similar to the RPA. So what we do in RPA is exactly for the machine learning itself, right? So we build the models and we have that particular independent model separately. So based on the business needs, all we have to do is spin up the new compute powers. What I mean by spin up the new VMs. So based upon the needs, the more a kind of a dynamic thing. So we handle that particular extra demand by adding few compute resources. So it's easier to scale the models up and down based on business needs easily, just by adjusting the compute resources.
Perfect. Yep. Anything else?
No, that was the last one thus far. So I guess if anyone else has any questions, please feel free to email one of us and we can get you back an answer really quick. The next session is on Thursday, and that one is also on AI, and it'll be by the same group. So thank you guys for joining today.